In this video we would be discussing about how nylon is manufactured and about its polymer system. Difference between nylon and aramid is that nylon has less than 85% amide linkages attached directly to two aromatics, but aramids have 85% or more amide linkages attached directly to two aromatics. And most importantly, nylon 6 and nylon 6,6 are isomers, and we know that one or more polymers having same chemical formula but different chemical structures are called isomers. Nylon 6,6 was the first nylon fiber and was produced in 1935 by Wallace Caruthers at DuPont's research facility. The basic information you can get on this slide is that nylon is not a generic name for polyamide but the brand name of DuPont's.
Polymerization of nylon 6,6 preparation of nylon salt, which is a compound, but not a polymer of adipic acid and hexamethylnediamine. The salt is prepared first to ensure the proper ratio of acid and hexamethylnediamine in the subsequent polymerization step. This condensation polymerization takes place in a free atmosphere. Water, which is split off during polymerization, is allowed to escape from the reacting tank. Titanium dioxide can be added to the material during this step. The molten polymer that forms is extruded from the tank as a ribbon, several inches in width. The material is quenched in cold water and then broken into smaller nylon chips. Polymerization of nylon 6 caprolactam is polymerized by one of two methods. 1st method, caprolactam is melted, heated and filtered under high pressure, during which process condensation polymerization takes place. 2nd method, water in the amount of 10% of the weight of the caprolactam is added. Polymerization takes place. In both these methods, a certain amount of monomer material remains. The polymerized material is given a water bath in an extractor to remove the monomers. Spin finish, a complex mixture of oil lubricants emulsified in water together with additional materials such as wetting agents, anti-static agents, and adhesives. The purpose of this finish is to lubricate fiber for subsequent processing and disperse static electrical charges that would interfere with yarn formation. Drawing, the stretching orients the molecules, making the fiber more crystalline, increasing luster, and improving tensile strength. The macro structure is the study of fiber's structure, mainly 1. Fiber length 2. Fiber thickness 3. Fiber length to width ratio 4. Color 5. Translucency 6. Luster. The microscopic structure refers to longitudinal and cross-sectional structure and appearance of fiber. Nylon is a linear, polyamide polymer. The nylon 6,6 polymer has a linear but zigzag arrangement of carbon atoms. The carbon can form 4 single covalent bonds which are arranged about the atom as the vertices of a triangular pyramid, i.e. a tetrahedron. This tetrahedral arrangement of bonds causes the carbon atoms to form a zigzag but linear polymer. This polymer configuration is partially responsible for the very good elastic properties of nylon. Chemical group in nylon polymer: polar amide group CoNH-, amino group NH2, found at the ends of the nylon polymer. These chemical groups are responsible to form the hydrogen bonds, and terminal groups provide the sites for dimolecule. Polymer system: the polymer system of nylon is estimated to be about 65 to 85% crystalline and about 35 to 15% amorphous. Tenacity: nylon has good to very good tenacity due to its very crystalline polymer system and hydrogen bonds. Elastic plastic nature: it has very good elastic property due to the very regular grid of strong hydrogen bonds in the nylon polymer system. Hygroscopic nature: nylon material is not absorbent material due to its very crystalline polymer system allows few water molecules to be absorbed. Nylon sold as anti-static nylon has had compounds will attract an increased number of water molecule because of the polarity of the O groups and will thus minimize the buildup of static electricity. Thermal properties: there is no satisfactory explanation as yet for the poor heat conductivity of nylon and its low heat resistance. Heat causes the nylon polymers to become excited, and this results in a breakdown of interpolymer bonding. The fact that nylon becomes limp when warmed illustrates this. The fiber burns in a flame but usually self-extinguishes when the flame is removed. However, nylon fiber do melt, and as with any fiber that melts. Chemical properties: nylon is less resistant to acids than it is to alkali. Exposure to slightly acidic conditions, such as perspiration or a polluted atmosphere, will cause some polymer hydrolysis on the surface of the filament or staple fiber. This changes their light reflection properties and results in a yellowing of white nylon. Prolonged and frequent exposure to alkalis will cause significant alkali hydrolysis of nylon polymer. The effect of alkalis on the nylon polymer is the same as for acid hydrolysis, namely, yellowing of the white fiber or dulling of colored nylon textiles. Nylon textile materials are inherently white and do not require bleaching. Nylon has only a fair resistance to sunlight and weather. This is attributed to the ultraviolet rays of sunlight causing the imino groups of the amide groups to react with the oxygen in the air. There are 3 methods that can be used to dye nylon textile materials, which are thoroughly explained in the slides. Mechanical properties of nylon. Strength. The strength of nylon is excellent. It is produced in a variety of tenacities. Modulus: strong fiber but has low modulus so that it stretches easily with little force. Resilience: not only nylon does recover well from stretching, but it also has excellent recovery from compression. This feature makes it ideal for carpets and rugs. Flexibility: nylon has low resistance to bending and can be flexed easily. Nylon fabrics are usually fairly drapable depending on their weight and construction. Dimensional stability: nylon has good dimensional stability at low to moderate temperature. At high temperatures, nylon fabric may shrink. Washing and drying temperature should be kept low. Abrasion resistance: this is one of nylon's advantages in many end users, such as luggage, upholstery, and sportswear. It is tough fiber, with extremely good abrasion resistance. In addition, nylon fabrics can be folded or flexed repeatedly without showing wear. Application of nylon. Nylon has long been of major importance in the manufacture of women's hosiery because it is strong and stretches and recovers easily. Sheer fabrics made of nylon have been popular because of their inherent strength and abrasion resistance. And other application of nylon are given in the slides.